the proportion of the divine beauty, maths, and nature, maths, and beauty. Please, look at these flowers and note the number of the petals of their corolla. These numbers are 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. And it is very hard to find flowers with a number of petals that is not one of these numbers. The spirals we can find in nature are also one of these numbers. We still find these numbers in fruits and vegetables. But what is the relationship between these numbers? Note that from the third number onwards, each term is obtained by adding the two numbers preceding it. Thus, we can obtain an infinite sequence, which is called Fibonacci sequence, by the Italian mathematician Lorenzo Pisano, better known as Fibonacci. Fibonacci invented this sequence from studying rabbit reproduction. Please look at the picture. A pair of rabbits, becoming mature, generates another pair. The number of couples over the generations gives the Fibonacci sequence. Now, let's look at them from a different perspective. If we calculate the ratio of each number to its preceding number, we can see that these ratios tend to be closer and closer to a special irrational number that mathematicians indicate with the Greek letter phi and call the golden ratio. This irrational number has a peculiarity: its reciprocal has the same decimal part as the number itself, and so phi equals 1 plus 1 over phi. This is really weird. Now, let's set aside numbers and talk about geometry. Let's start with a square of side A. Put the point of the compass on the midpoint of one side, and the pencil end on the opposite corner. Draw an arc. Use a ruler to extend the side of the square to the point where it meets the arc. This is how we obtain the segment B. So, we obtain two rectangles, a large rectangle, whose dimensions are A by A plus B, and a small one, whose dimensions are A by B. These rectangles are similar, and so we can write the proportion A plus B is to A as A is to B. A is the mean proportional between the value of B and their sum, A plus B, and, managing the proportion, we will obtain this statement. And we can find that the ratio A over B has the same peculiarity as phi. By applying to the proportion the cross-product property, we get this equation, whose acceptable solution is A is equal to phi times B. So, we can deduce that the ratio of A to B equals phi. If you draw a new square on the longer side of a golden rectangle, you will get one more golden rectangle. If you continue adding squares, you will get a sequence of golden rectangles, and by drawing quarter circle arcs connecting the opposite corners of the squares, we have a spiral, the golden spiral. In the same way, we can build a sequence of rectangles and the related spiral using the numbers of the Fibonacci sequence to underline that the ratio of two consecutive Fibonacci numbers approximates the value of phi, the golden ratio, that is considered a criterion of absolute beauty. And we can see that nature knows these spirals. And nature knows also the golden angle that measures approximately 137.5 degrees. Plants, in their growth, arrange their leaves using the golden angle. But why is it called golden? And where can we find this kind of beauty? In architecture. And in the human body. In graphic arts. And also in music, in painting, sculpture. But what do beauty and nature know about Fibonacci numbers, golden ratios, golden spirals, and golden angles? Is there something divine about it?
Mathematics is the language in which God has written the universe.